So we're going to look at examples 5, 7, and 8, the graphs of them, and just trying to justify the sine x over x squared. So the way we did it was we split it up as sine x over x, okay, and that limit we know is 1, and then we multiplied that by 1 over x, and we got this graph here. And we can see that the 1 over x, as it approaches 0 from the positive side, it's going to go up to infinity. And essentially this graph behaves like 1 over x. If we kind of scale it down a little bit, you can see that there are some bumps in here which represent the sinusoidal curve, the sine x over x part of it. So if I just kind of scale this down a little bit, okay, to that, you can see that these parts here, they kind of go up and down, and as they approach 0, though, they start behaving like the 1 over x, because this essentially becomes 1, and we're just taking the limit of that. So, taking a look at the other one, log of absolute value x plus 1 to the power cos x. So when we look at this, as it approaches 0 from the positive side, we can see that, yeah, it's definitely approaching 0. Okay, so our value of 0 is justified. Notice that we can't approach it from the left-hand side, so we needed a one-sided limit. So for the last one, I'm going to give you a preview of this, because this last one is particularly difficult. Okay, so this is example 8. As we approach log the x from the negative 2, as we approach negative 2 from the negative side, is going up to infinity. Okay, and if I just kind of scale this back, you can see that, yeah, at negative 2, we're going up to infinity from the negative side, and there's nothing going on in here. So the reason why there's nothing going on in between, although there's an absolute value here, what happens is between negative 2 and 0, these x values, we're going to end up with values of less than 1. Okay, so if we have their values of less than 1, the log value is negative, and we cannot have a negative base. So this log value here is the base of the cosine exponent. This base cannot be negative. That's just how exponents are defined. We cannot have negative bases. So these values in between negative 2 and 0 are excluded. There's an exclusion zone in there because of that negative base happening. Okay. Now the reason why it's going up like this is because as x approaches negative 2 from the negative side, we end up with negative, for example, negative 0.000 or negative 1.00001. So that becomes essentially 1. So we get log 0 from the positive side. Okay, so log of 1 from the positive side, which we take the log of 1, it's 0. So our base becomes 0 from the positive side. And then we have the cosine value here. So 0 to the power of anything should be 0. So why doesn't it go down to 0? It's because if we actually evaluate cosine of negative 2, negative 2 is in quadrant 3. Cosines are negative in quadrant 3. So we end up with 0 to a negative power, which puts a 0 in the denominator, which means we're approaching 0 in the denominator from the positive side, which means then that goes up to positive infinity. So that is a very difficult limit to do. Okay, so this one is extra challenging. So if you found this one difficult, and if you find this one difficult, so you should see the solution to this after this. It is quite complicated.